Hello and welcome to this introductory video on the magnetic Lorentz force. In this video we're just going to introduce the magnetic Lorentz force, provide an equation for how you calculate it, and describe how you figure out in which direction this force actually acts. So in previous video we introduced the idea of a magnetic field, and it shouldn't be surprising that then, just like the electric field or the gravitational field, that this magnetic field also exerts forces on particles. Now, what kind of particles? It turns out it only affects moving charges. It took a moving charge to create a magnetic field. It takes a moving charge to actually interact with a magnetic field as well. There's a nice symmetry there. So let's actually think about what's going on. So it's going to create a force on that moving charge. In order to calculate it, since it depends on being a charged particle and moving, it involves both the velocity and the charge of the particle, and of course it should depend on the field strength. All of these quantities are vectors, so we have to think about, does the direction matter? Turns out, of course, that yes, it does. The direction of the velocity compared to the direction of the field does matter, and the expression ends up being this. It is that the force, in terms of magnitude, is just equal to Q, the charge of whatever particle is moving in the field, times V, the velocity with which that particle is moving, times B, the magnitude of our magnetic field, times the sine of theta, theta being the angle between the velocity and the magnetic field vectors. Okay, so of course velocity and magnetic field are actually vectors. They have directions, so you can ask what is the angle between them, and that's what theta is describing. Then you get the magnitude of the force according to this expression. So that's all well and good, but how do we figure out the direction? Well, there's some kiting idea. First is that the reason you've actually got a sign there is you're secretly taking a cross product between vectors. There's two types of ways to take products of vectors. This represents a cross. If you had a cosine there, it would have represented a dot product. But there's an additional feature that when you take a cross product, the direction is always going to be perpendicular to both that of the velocity and the magnetic field. But that still doesn't actually specify exactly what that direction is. If you've got V and B in the XY plane, perpendicular would be along the Z axis, but is it up along the Z axis or down along the Z axis? To determine that last bit of the direction, you need to do some more right-hand rules, as we did for specifying the direction of B in the first place. Now, the way these right-hand rules work is you have sort of two choices. You can either remember that in the order of that product there, you're going to go and pick your first finger, which is your thumb. That will be the velocity vector. The second finger will be the magnetic field. That's your pointer finger. And then your third finger, put in a nice sort of coordinate system, your third finger is indicating the direction of that force. Okay, so you've got V as your thumb, B as your pointer. You line those two, and whichever way your third finger is pointing, that is telling you which way the force is. Equivalently, you can do the sort of open palm rule, which is pretty much the same thing. Your thumb is the first. Your whole set of fingers there is the magnetic field. Align them, and your palm points the direction of the force. Or you can use the slap rule, which is you imagine that you push the first vector in the product onto the second. So that means line up, say, if the velocity is going that way, and the B field is going that way, so let's just draw this in. So if you have a velocity vector that way and a B field going that way, then what's going on? So you line up your hand, your right hand, with that thing, and you push, and you get a direction. And as you do that, that direction that your thumb naturally points is the direction of the force.